enough of that. Chapter 9, Section 2, Solving Quadratic Equations by Graphing. We're going to solve a quadratic equation by... All right, that's enough of that. I can't keep that voice up. All right, how do we solve a quadratic equation? I'm just going to put quad. Oh, it looks terrible. Quad equation. Oh, quad EQ. Oh, that sounds like a DJ. Quad EQ by graphing. That's literally our essential question. If that doesn't get you excited, maybe I should sing my algebra song again. No, I don't think the world can handle it. Okay, let's jump into this and let's get serious. I'm ready to get serious. Just make sure you guys hit subscribe if you like the content. All right, hold on. Here we go. Oh. There we go. Let's just go. Oh, that's good. Okay. We have learned about linear functions. In fact, there are 3 forms. Slope-intercept form. Slope being m, there it is. Intercept being the y-intercept, b. Boom! Slope-intercept. Standard form. We've talked about this. If there's an a and a b and a c. Standard form. Point slope. You start with the point, x1, y1, and you have the slope. And you can write in that form too. And of course you can go between any of these forms using algebra. Or should I say, no, I'm just joking. All right. In each case, x is to the what power? Now, seriously, x is to the first power here, x is to the first power here, and x is to the first power here. So we're going to say x is to the first power in each one of these. So in other words, the input, and this thing, remember, doesn't do vertical lines. The input is to the first power. We've also started learning about quadratic functions where the exponent on the x is 2. So instead of being 1, right, as it is in linear functions, the highest exponent attached to x is 2. So we have the standard form of a quadratic function, and of course standard being, there it is, a, b, c. It's easy as 1, 2, 3. But if you look at this, the degree of this polynomial, if it was just standing on its own, would be 2, right? Because even though x is to the first power here, we always take the degree of the term with the greatest degree. So it would be 2. So the fact that there is an x to the first power doesn't matter. This x to the first power doesn't matter. All that matters is the greatest exponent with x as a base is the second power. Okay, and this puts us in quadratic function land. How many terms? 1, 2, 3, 4. Quad! It's got 4 terms when you have the function. Okay, let's go ahead and scroll down so we can see what else is down here. Okay, let's think about the x-intercepts of this quadratic function. All right, let's think about the x-intercepts. Where does an x-intercept occur? Well, if you're on the x-axis, what's your y value? It's 0. So an x-intercept has 0 for the y value. So let's set the y to 0. Now we have ax squared plus bx plus c equals 0. It's no longer a function in that we no longer have 2 variables, an input and an output, but this thing has a special name. This thing, ax squared plus bx plus c equals 0, is called a quadratic equation. It's a quadratic equation, and it's going to be really important in algebra. We're gonna study a lot about what this quadratic equation is all about. Okay, now, why is a quadratic equation important? Well, we're going to go over one reason today. How about this? Say I have this beautiful, amazing equation. X squared plus 2x equals 3, and we're going to solve it. That means we're going to find the value or values of x that make this equation true, and we're going to use graphing to solve it. This goes way back to things we learned earlier this year, where, I don't know if you guys remember this, but I hope you remember that we can take a one variable equation, right, one dimensional equation, and we can turn it into two variable equation for our own benefit, right? And we're going to do that here so we could figure out just the value of x. That's all we care about is what x equals. At the end of this, it's always a great question to ask. What's this going to look like when I'm done? It's going to look like x equals a number or 2 numbers, or maybe there's no solution at all. Okay, how can I make this look like that quadratic equation thing we were just talking about? Ax squared plus bx plus c equals 0. Well, what can we do to both sides? We can get rid of this plus 3, right? So we can make this right side 0. We'll subtract 3. Subtract, ooh, that was a fancy S. Subtract 3. Ah, vertical lines are the nemesis. Okay, subtract 3 from both sides, and we get this. That's a quadratic equation. ax squared plus bx plus c equals 0. Now, what if we said, I know that this is what the equation was basically to begin with, but what if we pretended that instead of 0, we had a y here, right? Then we could graph this equation in two-dimensional space, x and y, right? An x-y plane. And then the only values of x we'd care about were when y is equal to 0. In other words, all we'd care about are the y-intercepts. Okay, I'm going to have to get rid of what I've written so far, so hopefully you're pushing along here. Okay, now think about it. That 0 can be thought of as a y. Wait, thought of as y as being 0. I don't know, that's kind of weird. I don't know how I have too many as's in there. If y is 0, then what we are really looking for is the x-intercept. I typed x squared plus 2x minus 3 is equal to y into Desmos, and this is what it looks like, or this is what the graph looks like. I don't know what was wrong with me while I was typing this. Okay, I got this graph. And when I clicked on the x-intercepts, I got -3, 0, and 1, 0. Okay, that means when y is 0, in other words, that's the original equation I started with up at the top, when y was 0. So -3 and 1 must be the solutions to my original equation. Let me scroll down a little further and let's prove that that's indeed the case. So what x values give a y value of 0? -3 and 1. So the solutions are -3 and 1. Let's check to see if -3 and 1 makes this true. I'm going to substitute in parentheses, right? -3 quantity squared, always substitute in parentheses, plus 2 times -3 equals 3, right? That's one solution we're checking. -3 squared is 9, minus 2 times -3 is 6. 9 minus 6, does that equal 3? Yes, it does. So x is definitely equal to -3. We proved that that was the case, comma. Now we're going to try 1. And I know you're like, I already know it's going to work, but I don't care. I'm going to go through it anyway, and you just have to live with it. Okay, that 2 is beautiful. Equals 3. Let's see if this is true. Quantity, or 1 squared is 1, plus 2 times 1 is 2, equals 3. Yep, 1 plus 2 equals 3, so x must also equal 1. So what we did here is we solved this quadratic equation by graphing. A quadratic equation being ax squared plus bx equals c, and then we used the graph by making a 0 into a y, graphing it in Desmos, and then looking for the x-intercepts. Okay, so check these out. I did the same thing here. This is going to be really easy because the concept is simply that you convert this into a quadratic equation, and then you make it into a function with a y, and then you find the x-intercepts. Okay, first, make this into a quadratic equation. X squared minus 8x plus 16 equals 0. One of the things I don't like about algorithms like this, like first do this, then do this, is that you don't recognize it later on. Like, could you see that that's going to be a quadratic equation? What gives it away? You have an x that's being squared, and you have an x that's to the first power. That's what gives it away, because you know that ax squared plus bx plus c equals 0. You know you can convert that into ax squared plus bx plus c equals 0. Now we're going to make this a two-variable equation. Instead of 0, we're going to make it y. And then we're going to look for the places where y is 0 on our graph. So I type this function. Why is it a function? It's got input and an output. I type that into Desmos, and oh, look at this one. There's only one y-intercept, or x-intercept, which happens to be the vertex, right? So that means the only solution to this original quadratic equation, or even going back one more step, the only solution to this, since we're solving, looking for all the values of x that make this true, is x equals 4. Now I'm not going to show that because I'm afraid about losing too much time in the video, but 4 squared is 16 minus 8 times 4. 8 times 4 is 32, so 16 minus 32 is -16. Remember, guys, we kind of have our writing brain, right? And we have our thinking brain. And I like when both brains agree. So check this one out. And you guys probably already see, okay, I have an x squared, I have an x to the first. I'm going to solve this. Before now, I'm going to go back another step. Before, the only way we knew how to solve an equation that has an x squared and an x to the first power is by turning it into a quadratic equation, factoring it, and I don't know if you guys remember this, but using the ZPP, the zero product property, where you have factors equal 0, and then you set each factor equal to 0 and solve it. This solving by graphing is another way to solve these, and we're going to learn more, but for now, it's another way to solve it. So you know what to do. Set up a quadratic equation. Wait, quadratic equation? What? Oh yeah, ax squared plus bx plus c equals 0. So how can I do that here? I could subtract 2x and subtract 4, or I could just add x squared to both sides. That's what I'm going to do. So I get 0 equals x squared plus 2x plus 4. Now I have everything is positive. Oh, we live in optimism land. I hate writing over stuff, but this is the best I can do. All right. So here's our quadratic equation. How do we solve by graphing? Well, hold on. If we wanted zero product property, we could factor this, right, and set each factor equal to 0. But this section we're practicing graphing. So we're going to turn that 0 into y, make it a two-variable equation. Even though we don't care about the value of y, by making it a two-variable equation, we can graph it. And when we graph it, we get this beautiful, amazing graph. And what point on this graph do we care about? We care when y is 0. But what? This is where y is 0. Do you see that this graph does not have a range that includes y equals 0? So that means what? There's no solution. There's no solution to the original equation because this graph does not even touch the x-axis. It does not intersect it. So this equation has no real number solution. It has imaginary number solutions, as we've talked about with the complex number system, but there's no real solution. I'm going to try to finish all of these notes in one video, so bear with me and see if you can handle this. Okay, so these equations can have three different outcomes. What were the outcomes? Well, they could have two solutions, right, when the parabola has two x-intercepts. But if the vertex of the parabola, like on this example here, is on the x-axis, there's only one solution, or one x-intercept. And of course, in this example where you had the parabola was entirely above the x-axis, could be below it and upside down as well, there are no solutions because there are 0 x-intercepts. Okay, so what about this one? I'm going to leave this mostly for you because I don't have enough time. I'm going to run out of time here. Find the zeros of f of x equals x minus 3 times the quantity x squared minus x minus 2. In the past, when we talk about zeros, right, zeros mean, let me go over here. Zeros mean x-intercepts, right? But all we want is the x value of those x-intercepts, right? So it's the x-intercept, and all we want is the x value of the x-intercept. Before, to solve this, or to find the zeros, I should say, we set f of x to 0, we factored both of these, and then we used the ZPP, or the zero product property, to solve. But this time, you're going to simply type this whole thing in the Desmos. It's a little tricky. Make sure you're careful with your grouping symbols, your parentheses. And then you're going to just simply click on the x-intercepts, and then you're going to only give me the x values. That's all that matters here, because zeros are just the x values, not the ordered pair or anything like that. The x-intercept's the ordered pair. The zeros are just the x values. But then after you click on those x values, or those intercepts, do me a favor, substitute them back into x in your head and verify that they are indeed solutions, or create, or I should say, evaluate to 0. Thank you all so much. I'll see you soon. Oh, and don't forget to subscribe by clicking on my channel, and then there's exclusive content, and okay, bye.